Hey, hello everyone, Ranjit this side. So in this video, we'll be going through the time series decomposition. It's a part of the overall series of algo swing trading. This is my website. If you would like to go through the content online, you can also go through this website. Everything is already mentioned. Time series decomposition, it's a process of breaking down the overall series into multiple components. So when I say the multiple components, it trend, the seasonality, and then the residue that we have, it gives us a better visibility with, let's say, in terms of modeling the complexity, and it also helps us to follow which approach in order to let or model the each components correctly. In a time series, if we have a clear trend, then it can either be increasing or decreasing. In this, if you see, it's increasing. So one of the options that we have is to either we remove or extract the trend component from the time series before we model the remaining series, right? What it does basically, it helps us to make the series stationary, and then we can add it back whenever whenever we are done with the rest of the modeling part. Or otherwise, we can give the data, or let's say the enough data to the algorithm, and then it will model itself. But that is not the proper way, I would say, because sometimes we do not have enough data to give it to the algorithm, or let's say to the machine learning. Right, so we have two components in the time series. So one, we have systematic, and then we have non-systematic. When we talk about the systematic time series, it is characterized by the consistency which can be described and which can be modeled easily. So in the systematic component, we have level, which gives us a mean value in the series, and then we have trend. So the trend changes the value between the consecutive time points at any given point of time, or let's say the movement. The trend is, let's say, this one. So between every point we have a value, or let's say a consecutive the values between 2 points. Yeah, it can be either increasing or decreasing. So in this, it's increasing, but sometimes it can be decreasing as well. Right, and then we have seasonality. So it's a deviation from the main caused by the repeating short-term cycles, which can either be fixed or, let's say, be the non. Suppose we have a trend over here, so this is a straight trend, right? And then if we have something up and down, so this comes majorly because of the seasonality. For an example, I'll give you a small example. Let's say on in winters we have more productivity about on the apples, right? In India, so that we can say it's a seasonal, because that product comes gets produced on the seasonal basis. So that is what the seasonality is. When we talk about the non-systematic component, it's the noise. So it's the random noise, or let's say the variations in the time series, and then it consists of all the fluctuations that are observed after removing the components. For an example, let's say this is a time series trend that we have, right? And then if we have these kinds of, let's say, residues, then we can say that we have residue as well in the time series. We have the trend, and then we remove the trend, and then we have, when we remove the seasons, then we have the residues. In the time series decomposition, we have two types of models, or we can carry out time series decomposition in two types of models. One is additive model, and then we have multiplicative model. In the code that we will be doing, it will be a additive model, because there is a reason for that. I will come on to that. Now, what we do in the additive model, or let's say the characteristics of additive model, it's y of t. So we some level, we some trend, seasonality, and residue, or let's say the noise that we have, and then the changes over the time is basically consistent. So this is the additive model, and the changes, or let's say the trend and the seasonality and the residue, it's constant over the time, right? But that is not the same when it comes to, let's say, the multiplicative model. So multiplicative model is more of multiplying the level, trend, and the seasonality and the residue. And like I said, the changes over the time is not consistent in time, and it can be curved and non-linear trend, right? So multiplicative model is something like this. So the trend is not a straightforward line, and it can be non-linear as well. And then it can be increasing. So when we say multiplicative, if you see the seasonal, and the season is getting inconsistent, or it's not consistent with over the time. So it can increase or even can decrease more than what it was on the previous time of a point of time, right? So that's how the multiplicative model works. But then there are time series which are combination of additive as well as the multiplicative characteristics. For an example, what I mentioned is like the series with additive trend, and then we have multiplicative seasonality, right? So this is more of that example. So we have additive trend, right, and then we have multiplicative seasonality, right? Okay. Now, sometimes due to the model's restriction, we cannot have multiplicative model, right? It could be many reasons. One of the solution for that kind of model, or let's say for the multiplicative model, is to convert, or let's say to transform that multiplicative model into an additive model with the help of logarithmic transformation. So the idea behind is we use a log function to convert the time, the seasonality, and the residual, right, with the help of log. There are a couple of other points which we will come once we start doing the code work, right? I'll be using Google's Colab. I will be using NASDAQ data to employment rate. It's a monthly data. Before doing the coding part, you need to install the NASDAQ data link. You need to install the stats model. Then you need to import the pandas NASDAQ data link. So if you notice over here, the package name is different from what we are importing as a module, right? Or let's say the library. So please do make sure that you have a correct one. Again, from the stats model, we are bringing in the seasonal decompose. Then the API key, you have to make sure you are registering on the NASDAQ website to get this key. Okay, so what we are doing over here, let's run this first. So it's run perfectly fine. Then from the NASDAQ, we are getting the data set from the date of, let's say, 1st of January 2010 to 2019, this October, I think. And then we are renaming the columns as well. So why we are taking the data till 2019 is because since the COVID time, after 2019, it's a COVID time data, and then there is a big fluctuation when it comes to the data, and then the output that we are expecting will not be consistent. So the data that we are taking is till 2019. Okay, so when we run this, I'm passing on to this data frame df, right? So it's completed, and then normally if we do head, we will not get the data. So what we are doing basically, we'll be calculating the df. So right now, if you see, okay, let me show you the data. So we have unemployment rate over here, right? So this is mostly on the monthly level because the data available is on the monthly level in the data set, or let's say on the NASDAQ website. Then what we are doing, we are calculating the Windows mean and the standard deviation. Window size is 12, so we are taking the data on the yearly level, and then we are calculating the mean and the standard deviation, and the title name is employment rate. So when we run this, we have unemployment rate, rolling mean, and rolling standard, seasonal decomposition. And like I said, since the data is linear and consistent, we are using the additive model. If it was not consistent and linear, so we would have used multiplicative model, but we are here using the additive model, right? So this is what we get as an output. So here we have the overall trend, and then the seasonality, and this is a residue. Now if you notice over here, we have some high values of residues over here, right? So let's go back to the theory. Like I mentioned, we have trend, seasonal, and the residue, and then the random residues. To evaluate the decomposition, we can look at the random component. So in this case, if you see over here, like I mentioned, in the early stages of the data, we have higher residues, and then this can normally indicate that the seasonal pattern is not accurate. Now there are a couple of disadvantages when it comes to the seasonal decomposition that we did. So if you remember, we did the mean over here, right? So this is not good. Why? Because we are using the mean. So at the beginning and the end of the time series, we are basically missing the data, right? And then the seasonal pattern estimated using this approach is assumed to be repeating every year. And then every year, this seasonal pattern is expected to come. The trend line has a tendency to over smooth the data, which in turn results in the trend line not responding adequately to the sharp or sudden fluctuation. So since we are taking the mean and the standard deviation, so basically we are taking out, let's say, an average. So whenever there is a sudden sharp, or let's say the sudden fluctuations, so that might not be captured in the data, right, or in the trend. So yeah, that's all with the, I would say, the time series decomposition. And till then, take care, have a great day, bye.